I want to talk about titration today. And I want to start off about talking about titrating a strong acid with a strong base. And it's important to know what to do when you do these calculations, this sort of order you do things in. The first thing we need to know is the reaction that's happening. So for instance, if we titrate hydrochloric acid with NaOH, remembering that the sodium and the chloride ions are going to be spectator ions, and we're going to ignore spectator ions, we're left with H plus OH minus reacting to make H2O. This is the reaction we're doing when we titrate a strong acid with a strong base. The next thing we need to consider when we're doing titration calculations is the fact that we're mixing two solutions. I'm mixing my strong acid with my strong base, so there's going to be a dilution that happens. So let's assume we're following this example above, that we're titrating HCl with NaOH. And we can be more specific. We can say we're titrating 50 milliliters of 0.1 molar HCl with 0.0500 molar NaOH. And we can consider the situation after adding 90.0 milliliters of NaOH. And this is where we do our dilution calculations. 50 mils of my acid with 90 mils of my base. If I do that, the initial volume for my HCl is 50 milliliters. The final volume is 50 plus my 90, or 140. For my base, the initial volume is 90, and my final volume is the 90 plus the 50 for 140. They both have the same final volume. M1V1 equals M2V2, and these are the two concentrations we get for our acid and our base. Now at this point, we are ready to do the third step in the process, which is to set up our ICF chart. Remember, ICF stands for initial, change, and final, because those are the concentrations and the changes we're going to look at. If we do that, we need the equation that we're dealing with, H plus OH minus. Then we put our amount of HCl, 3.57 times 10 to the negative 2 here, 3.21 times 10 to the negative 2 for OH. These two are going to run until one of them runs out. The OH minus runs out, because there's less of it. So we have 0 of this left, and we have 3.6 times 10 to the negative third of H plus left in terms of molarity. Now we're ready for the last step, calculating the pH. Since we know the H plus concentration in this particular case, 3.6 times 10 to the negative 3, we can use the definition of pH. pH equals the negative log of my H plus concentration for a pH of 2.44. So after adding 90 milliliters of my NaOH to 50 milliliters of my acid, the pH is 2.44. So what happens if we add a little bit more of the NaOH? If we add a total of 110 milliliters of the NaOH. So we still have 50 milliliters of the 0.1 molar HCl, but now we have 110 milliliters of the 0.0500 molar NaOH. Well, we're mixing two solutions again, so we need to do another dilution calculation. So these are our new dilution calculations. The 50 milliliters is the initial volume of HCl again, but the final volume is 160, 50 plus 110. Likewise for NaOH, the new initial volume is 110, and the final volume is 160, 50 plus 110. Now we're at the same point as we were before, same steps, reaction, dilution calculations. We're going to set up our ICF chart. I've left the old ICF chart, the one from the previous problem, still up here because I want to compare this one to the one that we're going to generate right now. So this is the new ICF chart for our second calculation. You can see the 3.3 times 10 to the negative 2 goes right here. You can see that the 3.44 times 10 to the negative 2 goes right here. Those are our initial amounts. But I want you to notice, in the first problem we did, the OH was what we had less of, and the OH ran out. In this case, the H plus is what we have less of, and the H plus runs out. So we're left with OH minus. We don't have any H plus on our ICF chart at the end. So how do we find the pH? Well, we have to do it in sort of a roundabout fashion. We find the pOH first. OH minus equals 3.1 times 10 to the negative third. So pOH equals the negative log of that, which is 2.51. And because we're assuming we're at 25 degrees, 25 degrees, pH equals 14.00 minus 2.51, or 11.49. All of those things were for titration of a strong acid with a strong base. Now, if you have a weak weak acid instead of a strong acid, the steps are a little bit the same steps, but there's some slight changes, and I want to look at that now. So titration of a weak acid with a strong base. The steps are, like I said, follow in the same order. We need to identify the reaction we are doing. So we determine the reaction that happens. When you have a weak acid, we're going to represent our weak acid as HA. It reacts with OH minus to give you A minus plus H2O. That's the reaction we're doing when we titrate a weak acid. So the next step is going to be the same as in the strong acid titration. We're going to do our dilution calculations. So for the sake of argument, let's assume that we are titrating formic acid with sodium hydroxide. So we're looking at titrating 50.0 milliliters of formic acid with 0.050 molar NaOH. The formic acid is 0.01 molar. And what is the pH after adding 90 milliliters of the base? So if we calculate the dilution for this, HCHO2 is the formula for formic acid. The initial volume is 50 milliliters. The final volume is 140, 50 plus 90. For NaOH, it's 90 the initial and 140 for the final. These are our new concentrations. Now we're ready to fill out our ICF chart. So this is our equation. Our HA is HCHO2. Our A minus is CHO2 minus. And the 3.57 times 10 to the negative 2 goes here. 3.21 times 10 to the negative 2 goes here. We don't start with any of the conjugate base, but as the reaction proceeds, we make some of the conjugate base. As the OH minus goes down, the CHO2 minus increases. The OH minus is the one we have the least of. It's the one that runs out at final conditions, so we have 0. And you'll notice we have some of my formic acid and we have some of my formate when we're done. Now we need to calculate the pH. We want to be careful. Some people will look at this, oh, I have some of my formic acid. I can just plug into the definition of my pH. pH equals the negative log of H plus, and they'll put 3.6 times 10 to the negative third in there. You can't do that. It has to be H plus to use that equation. We are going to use this time the Henderson Hasselback equation. Because we have weak acid, we have weak base, we're going to use the Henderson Hasselback equation. I did not tell you this before, but in order to solve this problem, you need to know the pKa is 3.74. So we'll use the Henderson Hasselback equation now. My base goes on the top, my acid goes on the bottom. 3.21 times 10 to the negative 2 on the top, 3.6 times 10 to the negative 3 on the bottom. And when I put this into my calculator, I find that my pH is 4.69. So I want to look at one more case where we add 20 more milliliters of the NaOH. So we add a total of 110 milliliters of NaOH. Same problem, but more NaOH. We're going to do our dilution calculations again. So the numbers are a little bit different this time. We have 50 as our starting volume. We have 160 as our final volume. 50 plus, and I actually wrote the wrong thing, is times 110. It's 110 milliliters volume of NaOH this time, so 50 plus 110 is 160. 110 is starting for NaOH. 160 is the final. When we do our calculations, these are the numbers we get. We're going to fill out our ICF chart again. This time, I want you to notice that the formic acid runs out. I have none left. I can't use the Henderson Hasselback equation. I do have OH minus left. So what we're going to do is we're going to find the POH, the negative log of the OH minus concentration, in order to find the pH. We're not going to worry about the formate ion. It affects the pH a little bit, and if we were looking at it in more detail, we would have to consider that. For today, for our class, I just want on these problems to look at the OH minus concentration, and we'll find the POH based on that OH minus concentration. So my POH is going to be equal to the negative log of my OH minus concentration. Negative log of 3.2 times 10 to the negative third is 2.49. Well, if we assume we're at 25 degrees, the pH equals 14 minus the POH equals 11.51.